Chapter 21: The Theory of Consumer Choice. In this chapter, these are the questions we seek answers to. How does the budget constraint represent the choices a consumer can afford? How do indifference curves represent the consumer's preferences? What determines how a consumer divides her resources between two goods? How does the theory of consumer choice explain decisions such as how much a consumer saves or how much labor she applies? The budget constraint trade-offs. Buying more of one good leaves less income to buy other goods. Working more hours means more income and more consumption, but less leisure time. Reducing saving allows more consumption today, but reduces future consumption. What's the budget constraint? The limit on the consumption bundles that a consumer can afford. In example 1, Russell's budget constraint. Russell divides his income of $3,000 between two goods, steak and avocados. Prices are price of steak is equal to $10 per steak, and the price of avocados is $2.50 per avocado. Number A, if Russell spends all his income on steak, how many steaks does he buy? Number B, if Russell spends all his income on avocados, how many avocados does he buy? Number C, if Russell buys 200 steaks, how many avocados can he buy? Number D, plot each of the bundles from above on a graph, steaks on the horizontal axis and avocados on the vertical axis. Here's the two-dimensional graph. At number A, $3,000 divided by $10 gives you 300 steaks on the horizontal axis, point number A. Point number B on the vertical axis is $3,000, which is the income, divided by price of avocado, which is $2.50. That gives you 1,200 avocados at point number B. What about point number C? 200 sticks cost $2,000. The 1,000 left buys 400 avocados, and that gives us point C. Point D, number D, Russell's budget constraint shows the bundles he can afford. The slope of the budget constraint. From C to D, there's a rise of 400 avocados from 800 to 400. That is, minus you're losing 400 avocados. You are gaining 100 steaks from 100 to 200. That is the rise over the run. The slope is negative 400 divided by 100. That is negative 4. The slope of the budget constraint. This means that Russell must give up 4 avocados to get 1 steak. The slope of the budget constraint equals the relative price of the good on x-axis. Changes to the budget constraint. Initial problem, Russell's income was equal to $3,000 and price of steak was $10 per steak. Price of avocado was $2.50 per avocado. Show what happens to Russell's budget constraint if his income falls to $2,000. Number A. Number B, the price of avocados rise to PA equals $4 per avocado. Starting with initial budget constraint, now Russell can buy. Now $2,000 divided by 250, Russell can now buy 800 avocados. Or you can spend the money to buy 200 steaks, and that is the 2,000 divided by $10. All or any combination in between. And a fall in income shifts the budget constraint inward. As you can see, a left shift of the budget constraint. Answers B. Price of A or avocados increase. Russell can still buy 300 steaks since the price of steaks did not change. But now he can only buy 3,000 divided by $4, only 750 avocados. Notice the slope is smaller. Relative price of steak is now only 2.5 avocados. An increase in the price of one good pivots the budget constraint inward. Indifference curves. Indifference curve is a curve that shows consumption bundles that give the consumer the same level of satisfaction. MRS, the marginal rate of substitution. This is the rate at which a consumer is willing to trade one good for another. Example 2. Russell's indifference curve, or MRS. Points A, B, and all other bundles on I make Russell equally happy. Point C on I2, a higher indifference curve, is preferred to point I. The marginal rate of substitution is for the rise over the run. When marginal rate of substitution falls as you move down along indifference curve, at point number B, the marginal rate of substitution is 1. At point number A, the marginal rate of substitution was 4. So, marginal rate of substitution is the slope of indifference curve. 4 properties of indifference curves. Number 1, higher indifference curves are preferred to lower ones. People usually prefer to consume more rather than less. 2, indifference curves slope downward. The slope of an indifference curve is equal to the marginal rate of substitution, the rate at which a consumer is willing to substitute one good for the other. If the quantity of one good decreases, the quantity of the other good must increase for the consumer to be equally happy. 3. Indifference curves do not cross. If they cross, two different points on two indifference curves would bring the same satisfaction. This contradicts property 1. Number 4. Indifference curves are bowed inward. The slope of an indifference curve, which is the marginal rate of substitution, which depends on the amount of each good the consumer is currently consuming. People are more willing to trade away goods that they have in abundance. Downward sloping and bowed inwards. Downward sloping, if the quantity of steak is reduced, the quantity of avocados must be increased to keep Russell equally happy. Bowed inward, Russell is willing to give up more avocados for a steak if he has few steaks, A, than if he has many, point B. Example 3b. Higher indifference curves are preferred to lower indifference curves. Russell prefers consumption bundles I2 like C to every consumption bundle like 1 that is like A. He prefers every consumption bundle on I1 like A to every consumption bundle on I0 like B. Indifference curves cannot cross. Suppose they did, like the I1 and I4 crossing at A. Russell should prefer B to C. B is higher than C, since B has more of both goods. Yet Russell is indifferent between B and C. B and C should be indifferent. He likes C as much as A, both are on I4. He likes A as much as B, both are on I1. So it shows inconsistency. Extreme cases of indifference curve. Shape of an indifference curve reveals the consumer's willingness to trade one good for the other. Perfect substitutes. Two goods with a straight line indifference curves that is constant marginal rate of substitution. Perfect complements. Two goods with right angle indifference curves. So this is an example of perfect substitutes. Quarters and $1 bills always trade 4 quarters for $1 bill. They're perfect substitutes. And here, right shoe and left shoe are perfect complements. The indifference curves are at right angle. Perfect complements, left shoe and right shoe, the 10 left shoes, 5 right shoes combination is just as good as 5 left shoes and 5 right shoes, 1. Close substitutes and close complements. In the example of hamburgers and hot dogs, indifference curves for close substitutes are not very bowed. They're closer to being a straight line. Remember, a straight line is perfect substitutes. And indifference curves for close complements are very bowed. For example, socks and shoes. Optimization. The consumer's optimal choices. The best possible combination of the two goods. The combination of the highest possible indifference curves on or below the budget constraint. Optimum is where marginal rate of substitution is equal to relative price. The best bundle of the two goods that the consumer can afford. The point on the budget constraint that touches the highest possible indifference curve. Russell's optimum bundle at this point at A, where the indifference curve is just tangent to the budget constraint. So optimum A, Russell prefers B to A, but cannot afford it because B is above his budget constraint. Russell can afford D and C, but A is on a higher indifference curve. Marginal rate of substitution is the ratio of the price, P price of steak over the price of avocado, which is the slope of indifference curve is equal to the slope of the budget constraint. And that is what is happening at point number A. Changes in income. Normal goods definition: a good for which an increase in income raises the quantity demanded. Inferior good: a good for which an increase in income reduces the quantity demanded. A change in income shifts the budget constraint. A move on indifference curve. Example 7. Increase in income for a normal good. Kalia loves barbecue ribs and corn on the cob. The initial optimum is A. An increase in income shifts the budget constraint outward. If both goods are normal goods, Kalia buys more of each. The new optimum is point number B. That is, more barbecue and more corn on the cob. Active learning 3, inferior versus normal goods. For Matt, ribs are a normal good, but coleslaw is an inferior good. Show the effects of an increase in income. Matt's initial optimum is point number A. The new optimum is point number B, which means more barbecue ribs, move from this point to this point, but less coleslaw as you move down, because coleslaw is inferior. Income goes up, you buy less. Barbecue ribs is a normal good. Income goes up, you buy more. Example 8, effect of a price decrease. Russell has $3,000 of income. The price of steak is $10 per steak, and the price of avocado is $2.50 per avocado. Initial optimum is A. Price of steak decreases from $10 to $6. The budget constraint pivots outward. Now you can afford more steak. Russell buys more steak and fewer avocados. Steak goes from 100 to 250. Avocados go from 8 to 6. Avocado is now relatively expensive. Point C is the new optimum. The income and substitution effects. A fall in the price of steak has two effects on Russell's optimal consumption of both goods. The income effect. A fall in price of steak boosts the purchasing power of Russell's income, so he buys more avocados and more steak. That is the income effect. The substitution effect. A fall in the price of steak makes avocados more expensive relative to steak. Russell buys fewer avocados and more steak. The net effect on avocado is ambiguous. The income and substitution effects. Initial optimum is point number A. Price falls, and the new optimum is on the new budget constraint. Let's identify the substitution effect. From A to B, you move on the same original indifference curve. Okay? From A to B, he buys more steak and fewer avocados. Okay? You move from 100 to the new point and fewer avocados from 800 to the new spot. What is the income effect? From B to C. B to C is a shift. Income effect is a shift from one budget constraint to a new budget constraint. Substitution effect is a movement along an existing indifference curve. Overall, more steak and fewer avocados because the substitution effect dominates. Active learning 4. Substitution effect in two cases. Do you think the substitution effect would be bigger for substitutes or complements? Number A, draw an indifference curve for hamburgers and hot dogs. Number B, on a separate graph, draw an indifference curve for shoes and socks. Number C, on each graph, show the effects of a relative price change, keeping the consumer on the initial indifference curve. Active learning for answers. In both graphs, the relative price changes by the same amount. The optimum is at point number A, and it changes to point number B. But the substitution effect is bigger for substitutes than complements. Hamburgers and hot dogs are substitutes. The substitution effect, a movement from A to B, is larger than for complements from A to B in the case of shoes and socks. The substitution effect is bigger for substitutes than for complements. Deriving the demand curve. The demand curve reflects the consumption decisions. It shows the quantity demanded of a good for any given price. It's a summary of the optimal decisions that arise from the budget constraints and indifference curves. Example 9, Russell's demand for steak. We start with optimal choice point number A. When the price of steak is $10, Russell demands 100 steaks. $10, 100 steaks. When the price of steak declines to 6, Russell demands 250. You move from 100 to 250. The new point on the demand curve, the original point was A, the new point is C. When you joined these 2 points, A and C, you have a demand curve for the steaks. Application 1, the Giffen goods. Do all goods obey the law of demand? Suppose the goods are potatoes and meat, and potatoes are an inferior good. If price of potatoes rise, substitution effect would tell you people will buy less potatoes. Income effect would dictate that people buy more potatoes. If income effect is dominant or is greater than substitution effect, then potatoes are a given good, a good for which an increase in the price raises the quantity demanded. Optimum with low price of potatoes is as point number C. An increase in the price of potato rotates the budget constraint inward, which increases potato consumption if potatoes are a given good. The optimum with high price is point number E. Application 2, wages and labor supply. Budget constraint shows a person's trade-off between consumption and leisure. Budget constraint also depend on how much time she has to divide between leisure and working. Budget constraint is also the relative price of an hour of leisure, and it is the amount of consumption she could buy with an hour's wage. What about indifference curve? It shows the bundles of consumption and leisure that give her the same level of satisfaction. Wages and labor supply. The optimum is at point number A on the graph. The marginal rate of substitution between leisure and consumption is equal to the wage rate. Wage rate, if marginal rate of substitution is greater than the wage rate, then the value of leisure is greater than its price. So people take more leisure and work fewer hours to raise happiness. If, on the other hand, marginal rate of substitution is less than the wage rate, then the value of leisure is less than the price. So people take less leisure and work more hours to raise happiness. Application 2, an increase in wage. An increase in the wage has two effects on the optimal quantity of labor supplied. The substitution effect, or SE, a higher wage makes leisure more expensive relative to consumption. The person chooses less leisure, that is, increased quantity of labor supplied. People go to work. Income effect, on the other hand, i.e., with a higher wage, she can afford more of both goods. She chooses more leisure and reduces quantity of labor supplied. The substitution effect is greater than income effect. What is the result? When the wage rate rises, hours of leisure decrease. People work more from point number A to point number B. People reduce hours of leisure and work more. And hours of labor increases. Hours of labor supplied increase with wage rate, a positive relationship. What about the case of the income effect is greater than the substitution effect? When the wage rate rises, hours of leisure increase and hours of labor decrease. People work less. Hours of labor supplied decrease with wage. Now we have a negatively sloped labor supply curve. Application 3, interest rates and saving. A person lives for two periods. Period 1, you're young, works, earns $100,000. Consumption is equal to $100,000 minus amount saved. Period 2, you're old, you're retired. Consumption is equal to saving from period 1 plus interest earned on savings. The interest rate. The interest rate determines the relative price of consumption when young in terms of consumption when old. Application 3, interest rates and saving. Budget constraint shown is for 10% interest rate. For every $1 saved when young, get $1.10 worth of consumption when old. At the optimum A, the marginal rate of substitution between current and future consumption equals the interest rate. Active learning 5, a change in the interest rate. Suppose the interest rate rises. Number A, describe the income and substitution effects on current and future consumption and on saving. Number B, draw a graph to help explain. Substitution effect. The current consumption becomes more expensive relative to future consumption. Current consumption falls, saving rises, future consumption rises. Income effect. You can afford more consumption in both the present and the future, so saving falls. Graphically explained, this is consumption when old, and the second graph is consumption when old. A higher interest rate rotates the budget constraint outward. This is a case where substitution effect dominates the income effect. When SE is greater than IE, there is a decline in consumption when young and higher savings. So when you're young, you reduce consumption and you save more. When substitution effect dominates the income effect, that is, when SE is less than IE, consumption increases when young and lower savings. Think pair share. Your wealthy aunt dies and leaves you a great deal of money. If you get married, have children, stay with your spouse, and raise your children, don't become dependent on drugs or alcohol, and if you continuously have a full time job. Number A, why might your aunt include the requirement that you continuously have a full time job? Number B, does the evidence about how people behave after they receive an inheritance suggest that your aunt's concerns are well founded? Explain. What does this evidence suggest about the labor supply curve? Could you explain? Chapter in a nutshell. Consumers' budget constraint. The possible combinations of different goods she can buy given her income and the price of the goods. The slope of the budget constraint equals the relative price of the goods. Consumers' indifference curves represent her preferences. An indifference curve, various bundles of goods that make the consumer equally happy. Higher indifference curves are preferred. The slope of an indifference curve is equal to the marginal rate of substitution, the rate at which the consumer is willing to trade one good for the other. The consumer optimizes by choosing the point on the budget constraint that lies on the highest indifference curve. The slope of the indifference curve, or the marginal rate of substitution, is equal to the slope of the budget constraint, or the relative price of the goods. The income effect of a drop in price is the change in consumption that arises because a lower price makes the consumer better off. It is reflected in the movement from a lower to a higher indifference curve. The substitution effect of a drop in price is the change in consumption that arises because a price change encourages greater consumption of the good that has become relatively cheaper. Is reflected by a movement along an indifference curve to a point with a different slope. The theory of consumer choice can be applied in many situations. It explains why demand curves can potentially slope upward, why higher wages can either increase or decrease the quantity of labor supplied, and why higher interest rates can either increase or decrease saving.